Can you hear me? Can someone let me know whether I am audible?
Yes, ma'am.
Okay. Okay. So we will be solving 10th assignment today. Under this gauge transformation, this quantity changes to, so A prime mu will be equal to minus del mu lambda okay. So this will be a mu minus del mu lambda minus a mu plus del mu lambda these two quantities are same, so this gives us 2 times a mu del mu lambda plus del mu lambda, so this B option is correct. Now this is being repeated for 3 times now. You should, I think you know the answer by now. Can you tell me what is the answer? Under this transformation, what will be the transformed field strength tensor F mu nu? Hello? You are not audible.
Okay.
Can you write on the chat box? I cannot hear you. Yeah, yes, yeah. F prime mu nu is F prime mu nu will be del mu A prime mu minus del nu A prime mu, where A prime nu is A nu plus del mu lambda minus del nu A mu plus del mu lambda, and those two extra terms gets cancelled out because derivatives commute. So it gives us F mu nu. Okay. The wave function of an electron with mass m, electric charge E, that wave function satisfies the Dirac equation, and the form of the wave function is given to us, okay, where P is its 4 momentum and the Dirac matrices are given. What will be the 4 vector current J mu associated with this electron? Okay, that is the question. So since the wave function satisfies Dirac equation, so I gamma mu del mu minus m psi is equal to 0. We have to calculate the 4 vector current associated to this electron, and okay, so and we know how so this is the Dirac equation which the wave function of the electron satisfies, and then there was the conjugate equation of this form, I del mu psi bar gamma mu plus m psi bar is equal to 0. This is the conjugate. if we pre-multiply this equation with psi bar and post multiply this equation with psi, then we get I psi bar gamma mu del mu psi minus m psi bar psi is equal to 0, and from the conjugate equation we get del mu psi bar gamma mu psi plus psi bar psi, and if we add these two equations we get I, adding these equations, I psi bar gamma mu del mu psi plus del mu psi bar gamma mu psi is equal to 0. Basically these two terms get cancelled out, and okay, we are left with this equation, and from here you can see it is del mu psi bar gamma mu psi. So this is like the continuity equation, and from there we define the forecurrent to be J mu minus E times psi. Now we need to use this equation, this expression of the forecurrent to answer this question. So basically psi is given to us. We also know the Dirac matrices, so we can substitute here to get each of the components of the forecurrent. So for example, for mu equal to 0, okay, so J0 will be minus E psi bar gamma 0 psi, and you also know that psi bar is psi dagger gamma 0, so it gives minus E psi dagger gamma 0 coming from psi bar, and then there is another gamma 0, so those two gives us 1. We know gamma 0 square is equal to 1. So J0 will be psi dagger. Now what is psi? Psi is square root 2m times exponential minus I p dot x. So given psi is equal to square root 2m exponential minus I p dot x, then a column vector 4 by 1 column vector. So using this, J0 will be minus E, there will be square root 2m 2 times, so that gives 2m, then exponential I p dot x coming from psi dagger, and exponential minus I p dot x coming from psi, and psi dagger will give us this row vector, and then this is the column vector coming from psi. These two also gets cancelled out, and we are left with 2m, right, because this multiplication will give us just 1. So J0 we have obtained. We also need to know the other components of the forecurrent. So J1, J1 will be, let's see what J1 is. So for mu equal to 1, we get J1 minus E psi bar gamma 1 psi. So let's compute what psi bar is. Psi bar is psi dagger gamma 0. Psi dagger is square root 2m exponential I p dot x 1 0 0 0, and gamma 0 is 0 0 0 1 0 0 minus 1 0 0 minus 1. So this will give us, so this is a 1 by 4 matrix. This is 4 by 4, so we will get 1 by 4 matrix exponential I p dot x 1, then these will all be 0. So that is psi bar. Now we replace psi bar here and also use gamma 1 matrix. Okay, so J1 will be equal to minus E times, so again 2 times square root 2m will be there, exponential I p dot x coming from psi bar and exponential minus I p dot x coming from psi. Then 1 0 0 0 and gamma 1 is 0 0 0 0 0 1 1 0 0 minus 1 minus 1 0, and then psi vector, and it will give us minus E 2m. Let's multiply these two, so that will give us 4 by 1 matrix, and first element is 0. All the elements will be, first 3 elements will be 0 and last element will be minus 1, and if you multiply with this vector, this matrix, you will get 0. So J1 is 0. Okay, so yeah, so then the option could be either this or this. So let's check J3, because if J3 is 0 then the answer would be this, otherwise if it comes out to be 2m then this could be the answer. So J3, to compute J3, we need to use gamma 3. So psi bar we already have computed, exponential I p dot x 1 0 0 0, and then gamma 3 is 1 0 0 minus 1 minus 1 0 0 1. Minus E times 2m, and multiplication of last two matrices give us 0 0, third element will be non-zero now, 0, so this will again give us 0. So that means the answer will be B option. You can check J2 will also be 0. Let me just do it quickly. J2 will be minus E 2m p dot x 1 0 0 0, then this contains second Pauli matrix, so 0 I minus I 0, I think, no sorry, 0 minus I 0, then 0 I minus I 0, and 0, yeah, again the last element will be minus I, and this multiplication will give you 0. Okay, so the 4 current associated to the electron with this given wave function is this. Okay, 4 current density, yeah. Minus C2m and all other elements are 0. Okay, is this clear? Do you understand this solution, or should I repeat any part? We just need to know this definition and then use the Dirac matrices and the given wave function to compute all the elements. Okay. 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 So next question. An electron with 4 current density J mu is interacting with a proton at rest. The electrostatic potential associated with the proton is represented by the scalar function phi. The transition amplitude representing the interaction of the electron with the proton in this case may be written as, so so this is the case of interaction of a charged particle with a potential. So since the proton is at rest, so this is basically, and I mean, because of that proton there is this electrostatic potential, and the interaction is happening with the electron and this electrostatic potential due to that proton. So the transition amplitude formula was okay, so this is interaction of an electron with the 4 vector potential A mu, but A mu here is phi and all other elements are 0. Why? Because the proton is at rest. Only the electrostatic potential is non-zero. Okay, we need to find out the transition amplitude. So transition amplitude is defined as minus I psi f dagger v d4x. So if you remember how v, I mean what was v, this expression of v, so this is electron which satisfies the Dirac equation, but we will use the other form like not I, so I gamma mu del mu minus m psi is equal to 0, but for a free, so this is for free particle, we use the wave function to be the plane wave solution, and that if we substitute here we get the form of the Dirac equation to be gamma mu p mu minus m is equal to 0. Okay, so this is for a free particle, for a free fermion. And when there is electrostatic, when there is potential of potential A mu, then this P mu has to be replaced by P mu plus E A mu, where E is the charge of minus E is the charge of electron. So in principle this is minus Q times A, but here Q is the charge of electron because we are considering electron interacting with potential A mu. So P mu has to be replaced with P mu plus E A mu, and if we replace this here in the Dirac equation, we get the form of that V that we need to substitute in the transition amplitude. So P mu plus gamma mu A mu minus m is equal to 0, but okay, so P mu is P0 comma minus P vector. I am writing the covariant P mu, and P0 is nothing but E, energy of the electron, minus P. So I can we can write it as P0 minus gamma vector dotted with P vector plus E gamma mu A mu minus M. Sorry, did I miss anything? Yeah, sorry, is equal to 0, and then we can multiply with gamma 0, so that gives us E0, and E0 is nothing but P0 is nothing but E, so I replace that with E psi becomes gamma 0 gamma dotted with P psi minus E gamma mu A mu psi plus psi. So this quantity is what we need to substitute in the transition aperture. So this is the potential V, so transition amplitude is minus I psi f dagger minus E gamma 0 gamma mu A mu psi initial d4x, and this can further be written as psi f dagger minus E psi f dagger gamma 0 gamma mu psi I A mu d4x. But we know psi dagger gamma 0 is psi bar, so and this is this is J, as we saw in the earlier problem. So J was of this form, psi bar gamma mu psi, but here we have psi initial psi final because electron is interacting with the potential A mu, and we write it as J mu Fi A mu d4x. Now J mu is rho comma phi comma, it is given, yeah, J mu is rho comma J vector, and A mu is phi comma 0. So if you take dot product of these two, you will get rho phi, because J will be multiplied with 0, that gives 0. So yeah, so this is the transition amplitude. Okay. Meaning this D option is correct here. Do you understand this question? Answer to this question? So all you need to know is this formula of transition amplitude when a charged particle is interacting because of a potential, vector potential. Okay, and I am just taking dot product of these two vectors. Since the proton is at rest, in the vector potential, only the zeroth component is non-zero and all other components are 0, and dot product of these two vectors, these two 4 vectors, are giving us rho phi. Okay, now consider this process mediated by photon. Pi and Q are the momenta of the corresponding particles. The wave functions of the particles are given. Okay, which of the following correctly represent the transition amplitude of this process? So the process, if we draw pictorially, is like this. So this is the photon gamma, charge momentum q, initial particle is electron, mu1 minus, positron, P4, and wave functions are also given. So for electron it is u1, exponential minus I p1 dot x. For mu minus u3, p3 dot x. For positron it is v2 minus I p2 dotted with x, and for mu plus p4 exponential minus I p4 dot x. Okay, now so note, now there are two charged particles. So the previous question was interaction of a charged particle with vector potential mu, but now this is interaction of two charged particles. So for this case the transition amplitude is defined as, so the okay, so this is the interaction of two charged particles okay, and here the transition amplitude is defined as current. So if this current is J mu1 and current for this is J mu2, then J mu1 for photon, this is minus 1 over q square, J mu2 d4x, and J mu1 will be, so if you remember what was the expression of J mu, it was minus E psi bar final gamma mu psi initial. Minus E psi f bar final, where was that? Okay, I wrote it for another case, but yeah, so for this case it will be, so there is initial wave function, sorry, this is the initial wave function, this is the final wave function. So these two has to be substituted in this formula to get the current. Okay, so J mu1 will be minus E psi bar corresponding to mu minus, that is the final wave function. Okay, don't confuse this mu with this index mu. Okay, that is the particle mu, psi E minus. Now we can replace this in terms of what will be psi bar mu minus, it will be u3 bar exponential I p3 dotted with x, and psi E minus is u1 exponential minus I p1 dotted with x. So if I replace here, I get u3 bar gamma mu u1 and then exponential minus I p1 minus p3 dot x. Okay, and likewise J2 mu will be minus E psi bar, their final in this Here the final wave function is corresponding to mu plus. So psi bar mu plus gamma mu psi e plus, and mu plus will be v4 bar exponential I p4 dotted with x. Note this is the wave function for mu plus. So if we take it will be v4 bar then exponential plus I p4x, and psi positron is v2 exponential minus I p2 dotted with x. v4 bar gamma mu v2 exponential of minus I p2 minus p4 dot x. So transition amplitude becomes minus I times integration of j1 mu, that is this is gamma mu, okay, gamma mu u1, then the propagator corresponding to the photon minus e v4 bar gamma mu v2, and then the exponential factors p1 plus p2 minus p3 minus p4 dot x d4x. But these things are independent of x. I can pull it out of the integration sign. This is equal to minus I. This minus e times minus e gives e squared, and then remaining terms, okay, and the integration will now give us delta function. So minus I p1 plus p2 minus p3 minus p4 dot x d4x will give us a 4 delta function, minus I e squared 2 pi to the power 4 delta 4 minus p3 minus p4, and then these terms. Okay, so the correct option, if you see here, is option A. Is this clear?
Yes, ma'am.
Okay. The momentum exchange in the process of the earlier question would be, so Q, momentum exchange meaning the momentum of this photon, so Q is basically equal to P1 minus P3, but there is momentum conservation as you can see from this delta function. So basically P1 plus P2 is equal to P3 plus P4. So momentum exchange Q is either, you can write it as P1 minus P3, or that is same as P4 minus P2. So if we check the options, option A is the correct option, the momentum exchange. Okay, that is the momentum of the photon Q. Okay. Next question. Two monochromatic beams of particles A and B undergo scattering. In the lab frame, their three momenta are PA vector, which is P along z cap, and PB vector, which is minus 2P along z cap. Meaning this momentum is along minus z cap with magnitude 2P. Here z cap is the unit vector along the z axis. Their energies in this frame are given. Energy of A is E, energy of B is 2E. considering the normalization as defined in the lectures, so you need to refer to the lecture 37. So what is the flux density associated with this scattering? So I will take the formula of flux density from this lecture. So it was defined as, so flux density F was equal to, okay, so if A and B both are heading towards each other, so VA is opposite to VB, then the flux density is defined as 4 times magnitude of momentum of A times inertia of B plus magnitude of momentum of B, times inertia of A. So we can just replace from the question, magnitude of momentum of A is P times EB is 2E plus mod of PB is 2P and EA is E. So 4 times 2PE plus, so it gives 16 PE. Okay. Yeah, so this expression was given in this lecture, so you can refer to that lecture. And then just substitute the values of energies and magnitude of the momentum. Fine?
Yes, ma'am.
In the above problem, what is the relation between the masses of the particles? So, see, the energies are given, you also know the momentum. We can get the relation between mass of A particle with the mass of B particle. So for that, we just need to use the energy momentum relation. So E is equal to square root of P square C square plus M square C power 4, but we are using units where C is equal to 1. So EA will be equal to square root of PA square plus mass of A square, and EB is square root of, so these are the momentum, magnitude of the momentum square plus MB square. Okay.
Ma'am,
Yeah.
in the first line you write E equal to root over P square plus M square only. Why? I mean M square C to the power 4, that is M square into C square.
Yeah, that's correct. So energy is given as square root of P square C square plus M square C power 4. You are saying this, right? So we are using units where C is equal to 1 is equal to H cross. Meaning H cross and C both are 1 is what we have been using for this course, right?
Okay, ma'am.
Yeah. Energy of E is energy of A is E, and momentum was P, so P square plus MA square, and energy of B is 2E, and momentum is also 2P, so 4P square plus MB square. So I can replace E from here, so 2 times square root of E square plus MA square is equal to 4P square plus MB square. If I square, I get 4P square plus MB square, and from here 4p square gets cancelled out. It gives us mb square to be 4ma square. So from there mb is equal to 2 times ma. So C option is correct here. Is this clear?
Yes, ma'am, clear.
Okay. Okay, so yeah, so we are done with this assignment. Let me know if you have any other questions, or we can stop here. Yeah. Okay then, let's meet next week.
Happy Durga Puja, all of you.
Same to you. Yeah.
Thank you, ma'am.
Yeah.